Hello, in this session we'll look at more examples on past exam questions on algebra. In this question, we are given that the function fx is equal to 5 plus 3x. And in part A, we must evaluate f of minus half. A function is just a kind of a rule to tell us how to find a certain number. And when we say fx, it means that the number x will determine what the answer is. So the way to do it then is to substitute whatever value of x you have into the formula, the expression here, and then we can find the answer. So if we are given f minus half, that means that minus half is the x. And to find the answer, we must then put the minus half into the 3. And that looks like quite easy. Just replace the x by whatever number, in this case minus half. But there are some rules in algebra we must always observe when we do this. In algebra, if you have two letters or a number and a letter next to each other, then without anything in between, it means that we must multiply those two. So 3x really means 3 times x. But if I just replace the x directly by the minus half, it looks like 3 minus x, which is wrong. So the proper way to write this would be to put a bracket around it. So this would then tell us that we should really be multiplying 3 by minus half and not doing 3 minus half. Then, in the next step, we must multiply 3 by minus half, and the answer is minus of 3 over 2. And I end up with this expression where I have 5 plus minus 3 over 2. That's a rather awkward expression. Of course, we would understand that we are really adding these two numbers, 5 and negative 3 over 2. Still, it is less confusing if we put a bracket around it. So we're really adding 5 plus that number. Okay, and when we add a negative number, we are really subtracting it. So this is what it really means. 5 plus minus 3 over 2 is really 5 minus 3 over 2. And of course, with some practice, you should be able to jump straight from the first step to the last step without going through this. Alright, plus 3 times minus half gives you a minus 3 halves, and if you have a plus sign in front, then you can leave that out. So 5 minus 3 over 2. Right. To get this answer, we must convert, because we have a fraction there and we have another number which is not a fraction in this case. In order to add them, we must convert the 5 to a fraction with the same denominator. So to do that, the denominator is 2. I must multiply 5 by, I think of the 5 as 5 over 1 in the first place, right? And then to get a denominator of 2, I must multiply this by 2 over 2. Because 2 over 2 is just 1, it doesn't change anything, but it will give me a new denominator of 2 down here. So I get that, and then in the top of the fraction I'll get 5 times 2, which is 10. This becomes 5 becomes 10 over 2. Right. Now once we have that, we can then add the two numerators, or subtract the two numerators. That is 10 minus 3, which is 7. And that's the final answer. Right, let's move on to part B. In part B, we must find f minus 1 of x. Now in the last session, I've shown one way to do it. Let's try another way this time. Now I'm going to let y be f of minus 1x. So y is just a letter, just let it be that. Now in the next step, I can say that f of y is equal to x. Now this step looks a bit like I'm multiplying both sides by f. Okay, and if I multiply both sides by f and f minus 1 cancels, and I have an f on one side and x on the other side. Now, but we must be careful here, because f is not a number. F is a function. That means that it is a kind of a rule. So it's something more abstract than just a number. So f is not a number. It's not a number to the power of minus 1. It's not like 1 over f. Okay, it's a rule that says that it does the opposite thing of this rule. This is fx, that's f inverse of x. So f inverse of x is the inverse function of x, so it do the opposite thing of the function. What does that mean? Now if this function, the function f, when we are given a number x, this function of x gives us a new number. Right? It gives us this. Now the inverse function means that if we are given the answer, then the inverse function returns us the original x. It tells us what the original x is. So what it means is that if I have the inverse function of this number and it gives me y, then the function of y must give me x. Right, now that we are here, let us carry on. F of y, we can write an expression for this using f of x simply by replacing the x by the y. So since fx is 5 plus 3x, so fy we can get by changing the x to y. So 5 plus 3y is what this is. And we have that. Now remember that we really want to find f inverse of x, and that f inverse of x is actually y. We've given it the name y. What we have in this step is we have an expression here that has y and x, and that means that we have to find y, because y is the inverse of f, which is what we want. So in this step we must find y. We must solve for y, make y the subject. Okay, to make y the subject, I must rearrange this so that I have just y on one side and the rest on the other. If I look at this, I have 5 plus 3y. I can start thinking about getting rid of some of these. So let's start with the 5. I can get rid of the 5 if I subtract 5 from both sides. Subtract 5, subtract 5. So 5 minus 5 is 0. I have 3y. And on the right side, I have x minus 5. Right. Looks a bit simpler now on this side. I have 3y, and I don't have any y there on the right side. So on the left side, I have 3y, and I must do something to the 3. I really want just the y on this side. This is 3y means 3 times y. So I can get rid of the 3 if I divide this side by 3. Right? And I must divide the other side by 3 as well, so that left and right are still equal. And when I divide the right side by 3, I must be careful, because if you look at this, it looks like I'm doing x minus 5 over 3. And because we know that we must do the divide before the minus, it looks like I must do 5 divided by 3 first before I do x minus that. And we know that that's wrong, because the x minus 5 came first. I'm supposed to have calculated the x minus 5 answer before I divide that by 3. So to show this, alright, to make sure that we do this right, we have to put a bracket there to make sure that we do the x minus 5 first. So that's always a good practice when we multiply or divide one side of the equation, to put a bracket around the whole side before we times or divide. So now that it's quite clear, we can move on to the next step, and 3y divided by 3 would be the 3 and 3 can cancel. 3 can divide by 3 to get 1 and 1. So I end up with 1 times y divided by 1, which is just y down here. Now in case this looks confusing, let me write this part out in full. What this really means is 3 times y on top, and we have a divide by 3 at the bottom, which is the same as over 3. And I'm doing this cancelling here. And cancelling means that I'm dividing each of this number by itself. So 3 divided by 3 is 1, 3 divided by 3 is 1. And I have 1 times y divided by 1, which is just y. And on the right side, I now have x minus 3, x minus 5, over 3. And that is the final answer. Because we really want f inverse of x, and y is f inverse of x. Alright, so can let's call that f inverse of x equals to x minus 5 over 3. That's the answer. In this next question, we must expand the brackets and simplify 6k minus 2 times bracket 1 minus k close bracket plus 3. We start by removing the brackets. That's a little bit tricky because we have not only a number in front of the bracket, we also have a minus sign. Right. Let me do it one step at a time. I have a minus there, and I will be careful to concentrate on just this part of the expression to get it right first. So I'm going to put a big bracket around this 2 of 1 minus k. Right, let me do it this way. Let me put the whole of the minus 2 into this big bracket so that on the outside I have a plus. Okay, so think of this as 6k plus the whole lot, including the minus sign. So I've put this thing safely into the bracket, and I can now concentrate on removing the bracket of this thing inside the bigger bracket. To remove this bracket, the thing to do is to multiply each term in the bracket by the number outside. So the first term would be minus 2 times 1, which is minus 2, and the next term would be minus 2 times minus k. So 2 negative becomes a plus. Minus 2 times minus k is plus 2k. So that's what we have now. Right. Now that we have removed the inner bracket, let's remove that big brackets. When I remove this big bracket, it simply becomes minus 2 plus 2k. Right? The plus sign here simply means that we are adding. Right, the plus sign here with nothing in front of the bracket simply means that it is the same as a 1 times this bracket. So when we remove that, we're just multiplying each of these terms by 1. But the simpler way to think about it is that if we have a plus sign outside the bracket without any number, we can always just remove the brackets without doing anything. This is what we have now, and we can further simplify it by looking for like terms. And like terms means, in this case, terms that contains k and terms that do not. So these two terms, 6k plus 2k gives 8k, and minus 2 plus 3 gives, it's just 3 minus 2, and that is 1. So that's the answer for this part A. The next part, part B, we shall expand these brackets and simplify it. So this is a quadratic expression, meaning that when we expand it, we will get x squared. Right, let's do it step by step. Now in quadratic equations, we have learned that we can do it by taking all the possible combinations between the terms in the two brackets. But here, I'm going to do it following this method, following the idea of expanding the brackets, of removing the brackets. You can use either way. So here is just do it in a way to get some practice on removing brackets. Right, so let's start with this. Think of those brackets first. Alright, think of the brackets for that vector first. We want to start by removing those. And that means that I want to think of this whole lot as a single number. Now that's always the confusing thing in algebra. Alright? If you see a bracket with a few terms inside, it always looks complicated, and it's hard to imagine that that whole thing can really be just a number. But if you think about it, x is just a number, and if you know what x is, you can calculate everything in this bracket, and the answer is just a number. So let's try that. Think of the whole thing as a number, and now I want to remove those brackets. Now if I have a number here, when I remove those brackets, I must multiply this number by each term in the bracket. Let's do that. 2x minus 3, my number outside times the first term in the bracket and the number outside the bracket times the next term in the bracket. And then, because I have a plus sign in the bracket, I add those two. So I've removed one bracket. This is how it looks like. In the next step, we can now remove the remaining brackets. Well, actually I removed one set of brackets, but I've created a new one. But we know how to do it for each of this term. I think of this as one term and that as another term. In an expression in algebra, we think of terms as being separated by plus or minus signs. So let's look at the first term. I now want to remove these brackets. And x is the number outside. So to remove these brackets, I must multiply each term. Now I have two terms here, 2x and minus 3. I must multiply each of these by x. The first one is 2x times x, which is 2x squared. And the next one is minus 3x times x, which is minus 3x. Right? For the next part, to remove these brackets, I must multiply each term inside by 4. So 2x times 4 is 8x, minus 3 times 4 is minus 12. So that's done. And I must then add them together. So we have removed all the brackets. Finally, we should simplify this if possible. And to do that, we look for like terms. Now, those two terms contain x, so they would be like terms. Actually, the first term also contains x. But it does not only contain x, it contains x squared. And in algebra, we think of x squared and x as unlike terms. So that might sound a little bit strange, because since both of them contain x, why can't we think of them as like terms? So the thing to remember is that like terms means that if two terms are like terms, they must contain x, but they do not have to contain different powers of x, right? We might consider different powers of x, like x squared or x cubed, as unlike terms. Okay, now that we have found the two like terms, we can add them. Minus 3x plus 8x. It's like minus 3 apples plus 8 apples, right? And we should get 8 minus 3, which is 5x. 5x. And I should add them. Okay, because it's really 8 minus 3, I shouldn't carry the minus sign down here. Minus 12. And that's the final answer. We have expanded the brackets so that they are now gone, and we have simplified the expression. let's look at this question here. Y is directly proportional to the square of x. Given that y is equal to 32 when x is equal to 4, find y when x is 3. We start by looking at the first line. Y is directly proportional to the square of y, of x. We need to think about what that means. So we have y and we have the square of x, which is x squared. So if y is directly proportional to x squared, it means that y must be equal to x squared times a constant given by k. Now the idea of a constant means that it is a number that does not depend on x. So if x has a different number, this k should stay the same. If it seems abstract, just think of the k, just imagine a number like 2. Alright, so I would say, for example, y is equal to 2x squared. Just for example. But we don't really know what k is yet. Alright, so it's not really 2. Alright, so let me just cross it out. Right. And in a question like this, usually one of the things to do would be to find k. So that's our equation. Alright, we can think of that as our starting equation. In the next part, next sentence, we are given that y is equal to 32 when x equals to 4. So with this information, we could try substituting the y and x values into here. And hopefully that will help us to solve the problem. I will put 32 into the y and 4 into the x squared. Alright. Now before we do anything to it, it's always useful to read the question again and get some idea about what comes next. Right, that's a usual way of doing, a useful way of doing a problem, is to keep looking at the question again. Every 1 or 2 steps, look at the question again, and that helps you not only to understand the question better, but it reminds you of what comes next, and that often helps you to do the right thing. So in the next part, we have to find y when x is 3, and that means that if you look at this formula equation, we must find y when x is 3, and in order to find this, we really need to know k. Okay, so this part of the question suggests to us that somehow we have to find k first. So now let's go back and look at what we have up to now. We have 32k is equal to k, 32 equals to k times 4x squared. We have an equation with k as the unknown. Alright, this does not have this has been substituted with numbers for the x and y. So it means that I can now solve for k, which is what I need. K is the number that I need. Now I can square that. I can do a 4 squared, which is 4 times 4 is 16, and then I can divide that. Now, but it's sometimes useful not to calculate the numbers immediately. Okay, this is what I mean. I can think of the 4 squared as really the same as 4 times 4, right? Same as 4 times 4. Now the reason why it may be better not to multiply these two first is because you notice that you have a bigger number on the other side, which is 32, and that 32 is actually divisible by 4. So instead of multiplying out these two 4s, what I could do, alright, because I want the k, so I really have to get rid of the 4 times 4. So what I could do is I could divide both sides by 4 times 4. Okay, that means I divide both sides by 4 twice. And if I divide both sides by 4 twice, if I have to divide 32 by 4 twice, it's easier if I divide 32 by 4 and then by 4 again, because 4 is a smaller number than 16 if I were to square it first. So let's do that. Let me start by dividing both sides by 4. If I divide the left side by 4, 32 divided by 4 is 8. So on the right side I have k times 4 left. If I now divide this by 4, I have on the left side 2. 8 divided by 4 is 2, and then 4 divided by 4 is 1, and I just k times 1, which is 1. And that's the answer. That's k equals to 2. Finally, I must find y when x is 3. And let's go back to the formula relating y to x squared. We now know that k is 2. So let's write that out. Y equals to 2. Y equals to 2x squared. So it looks like my initial example where I wrote down y equals to 2x squared was a lucky guess. Okay, let's look at this. Find y when x is 3. This means that we must substitute x equals to 3 into that. 2 3 squared. Now again, this is where we have to be careful. When we start substituting numbers, we have to be careful, because if I just replace the x by 3, you can see that I now have something that looks like 23 squared. That's wrong, because really what we have here is 2 times x squared. That means that what I have here is really 2 times 3 squared. That's different from 23 squared. If I put a times in between here, is completely different. So there are two ways to write this. I can either, to be careful, I can either write this as 2 times 3 squared, or the other way to do it, which can also be easier, less confusing, is to put a bracket around it. Because once you have a bracket, the number next to it always means times. Like this. That's k times the bracket. Okay, so we must calculate the bracket first. 3 squared is 9. And then 2 times 9 is 18. So that's our final answer. Y is 18 when x is 3. In this question, we have to factorize completely 16p plus 4p squared. We can start by thinking about the factors for each term. In this case, 16p is the same as 16 times p, but 16 itself is, we can also think of it as the product of a few numbers. And if I separate 16 into a product of prime numbers, which are the smallest numbers I could separate the product into, it is 2 times 2 times 2 times p. So that's 16. And the 4p squared would be 2 times 2 times p times p added together. So I've separated each term into the smallest factors I can have. Now in the next step, I must then turn this expression, which is a sum of a few terms, into factors, meaning into expressions that are multiplied together. And the way to do this is to use brackets. I will start by looking at the separate terms and looking for common factors. In this case, I have p. P is common. Okay, there's only one p is common. That p does not have a common p here. And I have here the 2 is a common factor, and that 2 is also a common factor. So I have 2, 2 and p are the common factors. And for factors that are common among terms, I can take them outside of a bracket. This means that if I get ready a bracket here, I would take the common factors 2, 2 and p. So 2 times 2 times p outside of the bracket, and then I'll write down whatever remains inside the bracket. So what remains for this term is the 2 and the 2. 2 times 2. And what remains for that term is the p. And I must add them. That's it. I have just factorized it completely. Now, for the bracket itself, the bracket itself is one factor. Alright, so inside the bracket, I can simplify it, in this case by doing the 2 times 2 and writing it as a 4. So that's the bracket. It looks a bit simpler than writing out 2 times 2. Now for those outside the bracket, I can try and make that simpler as well. Now I know that in algebra, if I have a number next to a letter, it means times. I don't really need to write down the times symbol. So I can just put a p and I can leave out that times. Now for 2 times 2, I can write it as 2 squared. So that's our answer. We've just factorized this expression completely. In part B, we need to factorize this expression completely. So this looks a bit more complicated than part A. The thing to do is to look for terms that contain the same factors. Now even that is confusing because there are so many factors. There is the x, the y, the a, and then there are the numbers. So where shall we start? We could start anywhere, really. We could say, just pick a factor. We can try x or y or a or even 2 or 3. And you may find that sometimes for some factors, for some of the terms or factors, for example, you might find that if you pick x, it might not work, and then if you pick y, it might work. And this there is always some need to try it out and see. And if it doesn't work, you just have to try the next term. And you'll get faster with experience, with practice. So let's start. Let's start by trying x. Now, if I want to try x, what does that mean? That means that I want to look for terms that contain x. So that would be that one and that one. So let me put those two together. First start. X, y plus 3ax. And then put the rest to one side. This is what I have. Okay. I now have these two terms which both contain x. Now when we have two terms that contain x and we want to factorize it, the way is to take the x, the common factors, outside of a bracket. This means that I must first get ready a bracket, just throw a big one with lots of space in between. I must write the common factor outside the bracket, like I'm taking it out of the bracket, and then I must write down the remaining terms in the bracket. So I have y here and I have 3a down here, and I must put in the right sign, which is a plus. So I've just taken out the x, I've taken x out of a bracket, and I have in a way factorized those two terms. Now let's look at this other side. Now the thing about factorizing a long expression like this is that after factorizing two or sometimes three of the terms, we may have some terms left, and the hope is always that for those remaining terms, I can also factorize them. Not only that, and that after I factorize those remaining terms, hopefully that result would contain some factors that are common to this first part, and then we can carry on and factorize some more. But it doesn't always happen. If it doesn't happen, we might just have to go back, as I said, and I picked x just now, so I might have to pick y and try again. Okay. Alright. So we look at the remaining two terms and try and factorize that. I must first look for common factors. Now we can see a is a common factor. We can also see that 2 is a common factor because 2 is a factor of 6. Let's try taking those out of a bracket. I want to take 2a out of the bracket. Then what remains in the bracket would be y. If I take 2a from the 6a squared, now 6 is actually 2 times 3. So if I take 2 away, that sounds like I'm subtracting 2. But no, if I take away the factor of 2, to be precise, I have just the 3 that remains. And with the a squared, if I remove a factor of a, then a is left behind. And I must add them together. That's what I have so far. So let's take a step back and look at the whole thing. Now, look at those two terms that I now have, the two new terms, and see if there are common factors. And indeed, there is. If you look at this bracket and look at this bracket, they are exactly the same. As always, it could be confusing to look at a whole bracket and think of it as a factor, because we often think of a factor like 2 is a factor of 6 because 6 is 2 times 3. Just simple numbers. Or x is a factor of y because xy. X is a factor of xy because you're just looking at xy and it's obvious that x is a factor. But if you have a big bracket like this, it's not always easy to think of it as a factor because it doesn't look like a number. But as I've emphasized, you should think of the whole bracket as a single number. You don't have to think of it all the time, but you could, when you need to, you could imagine that the whole number is the whole bracket, the big and complicated thing in the bracket. You can think of this whole lot as just the same as a number, because in the end, if you know the values of the numbers for all the letters inside, you can actually calculate it and get a number. So try and think of the whole bracket as a single number, and you will realize that that whole bracket is a factor, and you have a common factor here, which is the bracket. So therefore, we can do the next step. Now we can factorize this some more. As always, when we factorize, we get ready a bracket, and we must bring the common factors outside of this bracket. Now, in this case, the common factor is y plus 3a. So that's what I must take outside the bracket. So I'll take those out. Put it outside of this bracket. That's my common factor. And then I must write down whatever remains in the bracket. So in this term, if I've taken out this bracket, I'm left with x. And in that term, after taking away the bracket, I'm left with 2a. And I must add them. So that finally is our answer. This times this. 2 brackets multiplied together. That means that we have just turned this expression into a product of 2 factors. I have factorized the expression completely. So this is how we can do such a question. We'll stop here for this session. See you next time.